The tiny Mercury spacecraft actually kept astronauts alive. But how? That's what we're going to look at on the next Vintage Retrospekt. Hello, I'm Chad, your host for Vintage Retrospekt, a small cramped place in this 1960s dining room. The Mercury space capsule, which was in service from 1961 through 1963, was a suborbital only craft that could seat one crew member for its 15-minute flight. Powering the Mercury spacecraft and keeping the astronauts alive was one of the development challenges that not only stretched research and development time, but also created opportunities for value-added inventions for NASA to reach the public. Now, the problem NASA had in developing this capsule was that they didn't even know what could happen to a human inside a small metal canister launched into space. Now, they had some data from sounding rockets launched that indicated that things could be super hot and super cold where there was an atmosphere and where there wasn't, but nothing really holistic. And yes, radiation was a concern, but there actually was radiation experiments run during the actual Mercury missions. The flight's trajectory was mindful of this and stayed pretty low to keep the exposure to radiation at an absolute minimum. The idea was to construct a spacecraft and over-engineer the design to build a vote of confidence to not only the selected Mercury 7 astronauts, but the public as well. Mainly constructed of aluminum and fiberglass, this machine was built by the McDonnell Aircraft Corporation. The capsule's outer shell was comprised of thin aluminum sheets that were embossed to what might be a method of cooling the capsule down during re-entry. So far, these mentioned features are important to set the stage of human survivability of this American-made craft. Okay, let's finally hop inside this craft and see what keeps the Mercury astronauts alive. At only 3.3 meters in diameter, you would think that this is a suborbital coffin waiting to happen. Well, to be fair, the spacecraft was over-engineered, so let's start with the outer and inner shell of the capsule. An inner pressure vessel made of titanium and a combination of a large pressure bulkhead that is seam welded to the inner pressure vessel comprised of the hull. Speaking of the hull, McDonnell had originally planned to not put a window on the side of the craft for the astronaut. You know, so they can get their bearing and verify orientation. Well, if you watch my Mercury Madness Part 4, I explain the short story and why this was what it took for the crew to finally get their window experience. I will link this video right up here and in the description. Actually, more on that window. It was a 3-pane sealed multi-layer window, which also included an image suppression feature to negate mirror images. Now, I'm not a glass scientist, but this probably indicates that multi-layers of glass create a 180 degrees flip reflection each time there is a glass-on-glass reflection. Pretty clever mitigation technique for the vintage times of space. Oh, and the windows were housed in a titanium bezel, you know, for that awesome strength to hold it into place. Now for the electrical systems. This system at its high level had a main bus and a secondary bus. Essential loads and non-essential loads were divided out using a fuse panel. Now, complementary to these panels were a set of 6 batteries. These batteries were a foundation of 3 total electrical power supplies, a main power supply, a standby power supply, and an isolated power supply. 3 batteries made up the main power supply. This was approximately 1500 watts and produced a combined 24 volts when wired in series. The standby system was around the same wattage, however, could only power the craft for about 1 orbit. Additionally, 12 hours of post-landing power was able to be part of its output requirements. Lastly, the isolated battery was used for the pyrotechnic systems. It was isolated because those systems cannot fail if the crew was to return safely in case of the 2 other power systems tried to cause a short or a cascade surge from a system power failure. A few systems where the isolated battery would power are the launch abort systems, parachutes, and a set of emergency beacons that would signal where the splashdown occurred. One thing that was cool was the isolated power system could be cross-fit to the secondary battery with a few astronaut inputs, but it would have to be carefully observed to keep its power levels low to around 500 watts, which of course was the typical power draw of the craft anyways. The ECS, or Environmental Control System, will be more or less what we would call the life support of the Mercury spacecraft. The ECS provided accurate and reliable control of gas composition, pressure, and temperature. A secondary function was to provide a satisfactory environment for the spacecraft electrical equipment by maintaining cabin pressure and temperature within suitable limits. The system design is partially closed, in which carbon dioxide is removed by chemical absorption, and then water vapor is removed by condensation and also stored. The oxygen is then recirculated by a fan. Water-cooled inverters were used for basic humidity mitigation. The system itself drew in at about 250 volts. There's more ultra-detailed information linked below with the official NASA documentation that I will link in the description. For now, we'll be briefly describing these systems since this is not a documentary. The ECS for the cabin is comprised of the cabin fan and cabin heat exchanger, a cabin pressure relief valve, a cabin air inlet valve, and the cabin air outflow valve. The cabin fan moves the gas to the cabin heat exchanger, which removes electrical equipment heat generation. Most of the switches and buttons were able to be controlled manually. The astronauts were essentially the human computers in the event of full manual control. All these switches must have connections using zero oxygen exposed wire. Any chance of spark? Well, we would have a pre-Apollo 1 scenario. My question is, if Mercury already took the proactive steps in wiring the craft with the respect of oxygen and spark prevention, how did Apollo 1 even happen? Let me know down below your thoughts on that. So now, do you feel safe being crammed into an over-engineered small tin can, squeezing both sides of your body? Also, be sure to like and subscribe to this channel so that others can learn more about the power and life support systems of Mercury and to feel more safe if they ever were launched like a Kerbal in space. And before I forget, I'm also the host on a new spaceflight show over at Orbital Edge. Please go check it out if you're new to space. I'm your host, Chad, and I will see you out on the launch pad.